Hi all, happy Thursday. Today we are just going to go through and do a whole bunch of probability examples, and those will be the notes for the day, so you can just follow along and pause me often to make sure you know where all the probabilities are coming from. You might need to slow me down a little bit and type things into your calculator and make sure that your answers are matching up, etc. Right here we have all of our rules that we talked about yesterday, our two big ones being the addition rule and the multiplication rule. And remember, the multiplication rule applies to independent events, so make sure you're looking for that keyword in many of the problems. Okay, so the first example says the probability that it will rain on election day is 0.29, the probability that a Democrat will be elected president is 0.62, and assume these are independent. So right there we see the independent events, which means that we can use our multiplication rule. So the probability that it will rain and a Democrat will be elected, so this right here means and, we're going to go ahead and use our multiplication rule. So that's probably that it will rain and the probability that a Democrat will be elected. So that is 0.29 times 0.62, which is equal to 0.1798. So now we want to know the probability that it will not rain and a Republican will be elected. So I know this isn't true, but assume that you can be only Republican or Democrat so that we can use the complement rule. So this is the probability that it will not rain and it will not be a Democrat. So once again, we're going to go ahead and multiply those two things together. So not raining, that's going to be 0.71. And I got that from 1 minus 0.29, the complement rule. If it's raining is 0.29, then not raining would be 0.71. 1 minus 0.29. Similarly, a Republican winning would be 0.38, because that would be not Democrat. So 1 minus 0.62 to give you 0.38. And that equals 0.2698. Now notice that here we have the actual events occurring. Here we have both complements occurring. But notice that these two numbers do not add to 1. So question 3 asks, why could we not simply take the complement for answer 1 and use it for answer 2? Why could we not do 1 minus 0.1798 to get this? Well, that's because the sample space exists of many, or a couple more options. So it could rain and a Democrat could win. It could not rain and a Democrat could win. It could not rain and a Republican could win. Or it could rain and a Republican could win. So those are all of our options. So we did this one, which was 0.1798. And we did the third one, which was 0.2698. However, this one has a probability of 0.1102. So that comes from a rain day, which would be 0.29, and a Republican winning, which would be our 0.38. Similarly, this one has a probability of 0.4402, because that would be not raining, which would be 0.71, times a Democrat winning, which would be 0.62. If we add now all these probabilities, every single option that could happen, those all add to 1. So you have to be really, really careful with the complement rule because there's different events going on. Alright, so the next example we have is looking at a chart of things we could eat for breakfast. So once again, it's telling us to assume these are independent. We want to know, are these items disjoint? So meaning, can any of these events happen at the same time, or are there no overlaps? So disjoint means no overlaps. So if we go through and we look at bagel, yogurt, cereal, and fruit, and we decide if this is a legitimate model, all of these probabilities add to 1.28. So we know that this is not a legitimate model, and so the items cannot be disjoint. There must be an overlap, since the sum is greater than 1. So someone has to be having more than just a bagel or more than just a yogurt. Some of these events can happen at the same time. Okay, the next problem is a little bit different. What's probably that the next 4 people will all eat cereal. So remember that these are independent, so once again the multiplication rule applies. So the probability that the next 4 eat cereal. So that would mean that of these 4 people, each of them are eating cereal. So that is really just 0.44 to the fourth, or, which is equal to, I should say, 0.03748. Okay, next we have a chart, and I like charts because I think that they're a little bit easier to read. So here we have some causes for fires. These are real data, and you may construct a similar experiment by looking for graphs or look at a newspaper or magazine. So that's just some extra information for you. So here are among 100 typical home fires. Now, one thing to do is I would just make sure and I would add the number reported up. If we add these up, we do get a total of 100 because you won't always have a total of 100 there. So you want to make sure that you divide to get the correct probabilities. So if it's a cooking fire, well, that was 15 out of 100, or 0.15. In the electrical wiring, well, that was 8. So that would be 0.08, or 8 divided by 100. Not smoking. Well, smoking is 0.07. So not smoking, we're going to use the complement rule. So that would be 0.93. Caused by heating systems, or, meaning plus, appliances, because these are all disjoint events. A heating system would be 0.22, or appliances, which would be 0.07, giving us a probability of 0.29. Cooking or smoking, well, cooking is 0.15, or smoking, which is 0.07, which gives us 0.22. Last but not least, can we estimate the probability that it was caused by lightning? Lightning is not one of our options right here, so we cannot estimate here. We know it has to be part of that 0.41, but we do not know exactly how much. Okay, our next example is dealing with 5 multiple choice questions, each with 4 possible answers. So 5 questions, 4 answers that appear on your history exam. What is the probability that if you just guess? So we are just randomly guessing. So the probability of getting any one right is going to be 1 out of 4 chance because there's 4 possible answers. So that would be 0.25 is a chance of getting it correct. So what's the probability that none are correct? So what exactly does this mean? This means that you got them all wrong, which means you got none of them right. So that would mean that getting it wrong, you would then have a 0.75 probability because 1 minus the 0.25 is 0.75. And remember that there's 5 multiple choice questions. So if you're guessing on each of them, that means that they're independent because your guess of one does not impact the guess of the other. So 0.75 to the 5th is 0.2373. Pause me and go ahead and try out B on your own. All right, so then what's the probability that you get all of them correct? Well, in this case, that would mean 0.25 to the 5th. So that would be 0.0009. Now keep in mind that in your calculator, this is giving it to you in scientific notation, so make sure that you can read scientific notation. Also, I would always recommend round to 4 decimal places. Okay, part C says, what is the probability that you get at least wrong? So this means either that you got 1 wrong, maybe 2 wrong, maybe 3 wrong, maybe 4 wrong, maybe even you got all 5 wrong. So rather than figuring out every single one of these probabilities, keep in mind that if you got 1 wrong, it could have been the first question, the second question, the third, the fourth, or the 5th. So there's lots of ways that even this could happen. There's also multiple ways that the second could happen, and so on. So whenever we see at least, we want to think of it as a shortcut. So this means that you did not get all right. So not all were correct. So the probability of at least 1 wrong is going to be 1 minus getting them all correct. And in part B, we figured out what the probability was of getting them all correct. So we subtract and we get 0.999. Part D. What's the probability that you get your first incorrect answer on the 4th question? So here we don't even care about the fact that there's 5 questions. We care about, though, and you can use good probability notation. I'm going to skip that part in this case. So here, that means that our first incorrect was on the fourth. So that means that the first three all had to be correct. So that means that this guy had to be correct, this guy had to be correct, this guy had to be correct, and then this one was wrong. Once again, because they're independent, we just multiply all those together, and we get 0.01175. Take a moment to read this last example and write down your givens, and then we'll go through the problems. Okay, so what's the probability that you had 2 or more semesters of calc? Well, that would mean that it's not included in the first 2 categories. So we're going to do 1 minus 0.55 minus 0.32, and that gives us 0.13. What's the probability that we had some calc? So this just means not none. So this includes the 0.13 and the 0.32 category. We add those up and we get 0.45. In other words, too, you also could have done the 1 minus the 0.55, and that would have achieved the same goal. What's the probability that you had no more than 1 semester of calc? So this means that you either had 1 semester or none. Okay, you can't have both, so these are disjoint events. So we are going to go through and add together those 2 probabilities. So 0.55 times 0.32 is 0.87. Okay, this last one's a little bit different because we're in a group of 3, and not including ourselves, we have 2 other group mates. So we want to see what the probability is that there are 2 other group mates, how much calculus experience they had. So neither studying calc, that would mean that both have had no calc, or both no calc. And we know that one group member does not impact the other, so they're independent. So that would be no calculus for the first one and no calculus for the second, which gives us 0.3025. What's the probability that both have studied at least 1 semester of calc? This means that both have had some calculus. So both have had some calc. We calculated that above to be 0.45. So at least 1 semester of calc means they've had 1 semester or more. So if both have had at least 1 semester of calc, that would be 0.45 squared, which is 0.2025. And last but not least, this one can be a little bit tricky. So this is saying at least one has had more than 1 semester of calc. Once again, there's that at least, which sometimes leads you that it's probably easier to use the complement rule. Another way to think about this would be that neither of them has had 1 or none. So 1 or none is that 0.55 plus the 0.32. So 0.55 plus 0.32, which was 0.87. So if at least one has had more than 1 semester, that would be that neither has had 1 or none, being the opposite. So we could do 1 minus 0.87 squared, knowing that this is not what we want, so we're going to take the complement of that at least one of them has had 2 or more semesters. And in that case, we get 0.2431. Alternately, you could think of all the different options. So pause me, and I'm going to list them all below. Alternately, you could look at the different ways this could happen. Both of your group members could be good, solid calculus background people, where they both have 2+ semesters of calculus. So they'd be 0.13 times 0.13. Or maybe one of them has had that and the other not, because remember we said at least 1. So maybe one of them did not. So that would be 0.13 times 0.87, where one of them had the experience and the other one did not. However, there's 2 group members, so this could happen in 2 ways. So we actually need to multiply that by 2. So now we have 3 different ways of that occurring. So we're going to go ahead and add those up, and we get that 0.2431. So there's your notes for the day. Go back, review as you need to. Take your time. We'll go over this tomorrow. Your homework is Math Excel. Have a great day.